Here's something most schools won't actually teach you in VCE chemistry. Try out this 2021 VCAA exam question. Connected cells have shown up more than once on the VCE exams. So how do you go about these questions? Well, the first step is always the same thing, and that is that you need to figure out the direction of electron flow. Thankfully for us in this question, it's already been given to us. But now that we know the electron flow, the next thing that we can do is find our anodes and our cathodes. So since the electrons are coming into this nickel electrode here, then we know that this is going to be our cathode. Then, as a result, it must be coming out of the following electrode. Therefore, this is our anode, so on and so forth. So therefore, into this electrode, cathode, and the final one here is your anode. So now that you've found your anodes and your cathodes, the third step is to treat each cell as being separate. So here, the question is asking us for the energy transformations that occur in each of the cells, which means we need to figure out which cell is galvanic and which cell is going to be electrolytic. So if we look at the half cells here, what we can see is that we have our copper 2 plus copper solid half cell alongside our zinc 2 plus zinc solid half cell. Our copper 2 plus half cell is our cathode, meaning the copper 2 plus is going to undergo reduction, and our zinc half cell is the anode, meaning this undergoes oxidation. So as a result, this gives us our downhill gradient between our two reactants there. Therefore, this cell is going to be galvanic. So for the following cell, we have our nickel 2 plus and our copper 2 plus half cells, in which the copper should be oxidizing as is the anode, and the nickel should be reducing as is the cathode, therefore giving us our uphill gradient, meaning this cell here is going to be an electrolytic cell. So now we can go ahead and find the answer, because as we know, in our galvanic cells, we start with chemical energy and convert to electrical energy, and in our electrolytic cells, it is the reverse. So therefore, the answer should be C.